Okay, so now I wanted to take a little bit of time to look at our homework assignment for chapter 1, really reinforcing the ideas that we've been talking about through the PowerPoint and the work that we've been doing here in the lecture. So, so as we look at assignment number 1, when you click on the assignment, you're going to come up to these problems from the end of the chapter that you're going to be looking at. And these start on pages, it goes from pages 25 to 30. And that's where all of the assigned or end of chapter problems are for this book or for this chapter. So you're going to be assigned to do the kinematic diagram for the first 6 problems that are identified here. So number 1, 3, 9, 10, 11, and 24. Okay. And then correspondingly for each one of those, number 26 is the mobility equation for 1-1. And then number 28 is the mobility equation for 1-3. Okay. So when you read the instructions, this is consistent with that as well. So let's take a peek at some of these kinematic diagrams just to be sure we have a good idea on, you know, what they're going to look like. And then what I'm going to do, I don't know why this is so like, seems dim. Can you guys on Zoom, can you guys see my stuff pretty clearly here? It feels like, it seems like it's kind of like grayish or
like it's slightly blurry, but definitely legible.
It's legible. Okay, so then always reference your book. Hopefully
it is fairly dark, but we can still read it.
I don't know why it's dark because I have a light on underneath here. I'm not sure. And I'm going to see if turning off this for you guys because I noticed that too. I don't know how to use these lights sometimes. How do you turn these off? Oh, I think I got to be patient. I'm trying to control the lights inside here. There we go. Got to hit the bottom one first and then the top. Did that change? Did it get darker for you guys online? Or is it okay?
I mean, it's fine. I can.
It's fine. Okay. All right. So for our first mechanism here, this is problem 1-1. It says this mechanism is going to be used to open the door of a heat treating furnace. And it is shown in the picture here. Draw the kinematic diagram of this mechanism. The end of the handle must be identified as a point of interest. Okay. So we're going to make a simplified kinematic diagram of this. And as we approach this, we want to kind of first look at, okay, where is our frame? You know, where is something going to be connected to that it's not going to move? And then what our different elements are going to be, meaning what are the different links? So we have a handle, right? That handle, you'll notice, pivots around this point, which is on the actual furnace itself. So this is going to be our frame member. Okay. And so our handle is going to be connected to that. And it's going to also be connected to this connecting rod or coupler to what would be the door going up and down here. Okay. And then it is constrained vertically, you know, within the confines of that track. Okay. Don't have to worry about what that track looks like, but we're going to have our frame, our handle, connecting rod, and slider. Okay. So in this case, you're going to draw the kinematic diagram for this. And then correspondingly, number 26 on page 29, you're going to determine the mobility for figure P 1.1, which is problem 1.1. So figure P 1.1 goes along with this, and you're going to notice it's problems 1 and 26. Okay. So let's just go ahead and just sketch the kinematic diagram for problem 1-1. So starting with our frame. Okay. Zoom out a little bit here on my paper. So this is going to be problem 1.1. Okay. Starting with my frame, I think I'm going to show that probably going up so it stays out of the way, if you would. Okay. And then my handle is coming across. Oh, I missed the point. Going through. Okay. And it's connected to the connecting rod right there. And I'm going to give that handle a little bit of thickness just so we can see this as a continuous piece rather than two separate pieces with a joint in the middle. And then our handle is going to have a special interest point. Then the handle is connected to the slider through that connecting rod. And then the slider, now again, we're not worried about, you don't want to make this super wide at the bottom. We're not representing the actual part itself. We're representing the motion that's occurring. So this is going to be a slider. And then we're going to have a vertical constraint. Now, again, no dimensions are there, so we're just putting it in proportion. Now we're going to add our labels, number 1, 2, 3, and 4. And then we're going to add our joints, A, B, C, and D. Don't forget the one by the slider. It's easily forgotten. And then the second part of this, so this would be problem 1.1, and then problem 1.26 would be the corresponding mobility. Okay, so then that mobility equation is going to be m is equal to 3 times n minus 1 minus 2 times jp. So this is, again, a good check. Don't just, copy paste the equation or just write it out blindly. Double check that you have all the labels that you're supposed to. So my n, how many links do I have? I have 1, 2, 3, 4, and I do have 4 labeled. So it's going to be 3 times 4 minus 1 minus 2 times the number of primary joints. So I have an A, B, C, and a D. So if you forget the D on a slider, you're only going to see 3 and that won't come out, right? So I have 4 primary joints. So I've got 9 minus 8. M is equal to, oopsie, 1. There we go. Now this portion would be in CAD. All right. And then this can be hand drawn on the side if you want to do it separately. Okay. Any questions about problem 1.1 and 1.26 on what's like required, if you would? And then you're going to use the same formatting, CAD for this part. You can handwrite or add it to the CAD if you want to for each one of those problems. Okay. Let's look at each problem, and you can stop me if you want to see how to do the kinematic diagram for any one of these. Okay. So that was our first one. That was our heat treat furnace door. The next one that we have here is going to be the stadium seat. Okay, so problem 3 is the stadium seat. Problem number 28 is the mobility equation that goes along with it. Okay, so both parts we want to do. Does anybody want to see the kinematic diagram figured out for the folding chair for a stadium? Okay. You can always ask me, at another time if you want to. The next one we have here is another version of the toggle clamp. So very similar to the one that we looked at earlier as an example, but not exactly. A little bit different configuration on the links, but a similar type of a product. So kinematic diagram would be problem number 9, and the mobility equation is going to be problem number 34. Any questions on this one, or does anybody want to see this one laid out diagram wise or mobility equation? Okay. Then we've got, oh, here it is, the scooper. The scooper, got some numbers on here. Hold on, I'm going to erase these for now because I don't want those to influence necessarily what you're going to do, or you think that those have to be those numbers. As we look here at this mechanism, this is the one that you're going to have a mobility of 2, because you have to do 2 things. There's 2 handles there, right? In order to get this to scoop the sand, to move it. So are there any questions on this one? Yeah. Yeah, okay, yeah, let's look at the diagram because it is a little bit different, okay? So as we look at this mechanism, first of all, the chair portion is going to be like in the ground, right? So this point right here, this is going to be our frame, right? That's going to be our frame. That one's always going to be in the same place. And then we have to look at what are the like solid pieces here. So one of the solid pieces is this sideways T. This is all one piece right here, which is one of the handles. And then another solid piece is the scoop part, okay? The other ones are, you know, kind of straight ones, right? So we want to be sure when we represent those that we see them as their individual pieces. And, you know, if they're a little bit different configuration, we might not be able to just do a triangle. We might have to make it look a little more like the piece, and that's okay. Might have to do that once in a while. So with that, let's take a peek. So this is problem 1-10. And we're going to do the kinematic diagram first. Okay. So we know that our slower. This is going to be our frame member down in that lower right-hand corner at the bottom of the seat or the chair. And then connected to that is that sideways T, that first handle, right? So to show that, that one's going to be connected here. It's going to go straight up to its handle, okay? And then it also has a connection and it goes all the way out over here, okay? And it has a connection, let me see, it has a connection here. And it has a connection at the end, okay? Now, to make this look like more than like one piece rather than a bunch of little ones, we got to kind of be strategic with our placement. Kind of see what I did there? I know it looks very different, but it also emphasizes that it's one point. If we would just show this going up and then over, this would look like a separate link that would have joints at the end of it. And that's not what it is. This is all a solid piece. Okay. And so, you know, however you make this look, you can maybe make it. What do you mean wrapping around? It's just, this is that point. Okay. Yeah. It's just supposed to be the end point right there. Okay. So this end point is that right there where it connects to the scoop. And then that other point is going to be where it connects to that other vertical handle. Okay. And then if you would, you don't have to put this on there, but that's the top of the handle for that one. And again, if we would show this, for instance, going like this and like this, we would show it like this. And then it doesn't, it's like, how many pieces is that? It doesn't look like one solid piece if we do that. You know what I mean? This would look like two separate pieces, right? So that's why this is not a good way to show it. You want to give it some thickness. Okay.
Well, that's not a joint there below the middle point there.
Here, and here. That is a joint, yes.
Oh.
That is the joint for this one right here.
I meant below that one, but not.
This one?
No, in between.
Here? No, there's no joint there. I don't have a circle. Remember, your joints are represented with circles that are filled in. This is not a joint. This is just coming together and yeah. Now we're going to show the piece, the handle going up. So the handle goes straight up here. Okay. And then in the middle, it has a connection point. Now here too, this handle looks like it's two separate pieces, but it's not. So give it a little bit of thickness by adding like a triangle to it so that you know that it's one solid piece. And then here would be the, you know, the other handle if you would. Now the horizontal member going straight out here, that simply is a horizontal member that has the two endpoints. So we just did our handle, and then here's the horizontal member, just a line. And then now we have to do our scoop. Okay, our scoop connects to the endpoint of that horizontal member. It connects to the endpoint of the sideways T. And then the scoop down here, this would be a special interest point. So again, this can look a couple different ways. So we're first going to connect these two. Okay. And then you can come out like this, kind of make it look like a scoop, you know what I mean? Something like that. It is, it is. Yes. Well, if they point it out, yes, or if there's obvious ones that you're like, yeah. So like the end of the scoop here definitely will be a point of interest, yeah. And then probably the ends of these two handles too, because you got to kind of know how far you're going to be pulling those. Like, because then the judgment would be if it's for you know, a kid in a playground, you might want to, you know, you don't want it to be too far that they wouldn't be able to do it, right? Yeah. So that's a diagram. Now, if you made it look a little bit different, but it is distinguishable to see the separate pieces, that's totally fine. Simplified version. So now as we look at our numbers and letters, this would be number 1 would be my frame. Number 2 would be my sideways T. Now, again, these numbers after number 2 all the way to the end are arbitrary. I'm going to call that number 3 my second handle. My 4 is the horizontal bar. And I have 5 for my scoop. Anywhere I have a dot for a pin joint is now going to be a letter. So A at my frame, B. I'm going to call this C just because it's on the same member. If you don't do that, that's okay. C. Then I'm going to go here, D and E. And then special interest points. I'll move my number 3, probably should be down here. We'll call an X, a Y, and a Z, right? X, Y, and Z. Now you're going to make this look so much better when you do it in CAD. Okay. Now we're expecting to get a mobility of 2 here, right? There's 2 handles. I should get a mobility of 2. So let's check it. My mobility is equal to 3 times n minus 1 minus 2 times JP. 3 times. Now, and this time I have 5 links, right? 1, 2, 3. Wait, 1, 2, 3, 4, 5, including my frame. So this is going to be times 5 minus 1, right? Minus 2 times my primary joints, A, B, C, D, E. So that's 5, right? Instead of 4. So 2 times 5. So I've got 4 times 3 is 12, right? 12 minus 10. My M is equal to 2, which is exactly what I need to do to make this work, right? 2 handles. Can anybody think of another example where we see mobilities of greater than 1? Pedals on a bike. Well, not really. On one side, you would look at it. Yeah, that would still be a single because you're only doing that cranking motion. Yeah. Any others you can think of? I don't have experience doing this, but I'm thinking of one. What about, again, I've never done it, but I see how it's operated, I think. What about like a bulldozer? They have like levers, right? That they have to do a bunch of different things, and there's mechanisms there that are gonna, you know, scoop and push and all that kind of stuff. You gotta be kind of trained to do stuff like that, right? It's not something that you can just walk up to and start probably working with, right? Backhoes, kind of that same thing. You've got a bunch of levers that you have to actuate in order to get something to do what it's supposed to do. Those mobilities are greater than 1, okay? So, and they're not as easy to use. They're not as easy to use. Okay. All right. So that's problem 1-10 and 1-35. So the mobility part is problem 1-35. Okay. So we got 4 of your 12 problems done already. Look at that. Okay. So we looked at that one. Let's look at another one. So the bottom here is 111, but the illustration is at the top here. This is a reciprocating saw. And when we show a reciprocating saw, you'll notice that it's attached to what would be like a flywheel, if you would, okay? But when we represent it from that center of that circular disc here that our connecting rod is attached to, it would just be a straight little line here for that radius from the center of rotation to where it's going to connect to that, okay? Does anybody want to see the diagram for the reciprocating saw? This is a crank slider. So this is going to go around, right? And then the slider is going to go back and forth, back and forth. Okay. When you say just, it's just a little line right here. It's going to go from the center, which will be your frame. And then it's going to go to the point of the connecting rod. Yep. Yep. They're both crank slider or slider crank, however you want to say that. Yeah. So does anybody want to see this one? You feel comfortable with that configuration? Okay. And then the mobility would be number 36. Okay. And then we've got number 24, which is the sewing machine, but the illustration, don't do this one down here. Go up to the top. Okay. And this is going to be the last diagram that you do then. Okay. So number 24, and then the mobility is number 49. Here too, just like that reciprocating saw, this is the center of rotation and it's attached here, but you're just going to draw it just like this. This is going to be my frame. And then you've got just that radius there. Okay. And then here's your connecting rod. And right here is your slider. Everybody see that one? Okay. Special interest point here might be just a simple line going all the way down to represent where that end of that needle would be, right? But the sliding action actually happens up on top where the end point of that connecting rod is. Okay. And then the mobility would be number 49. So any questions on this one? Anybody want to see this one? Okay. If not, then those are the drawings, the kinematic diagrams with their mobility equation problems. Okay, those are the ones that you're going to do. And remember, this all is done. I would suggest sketching it in, out first in pencil, but you will need to submit the CAD version. And then what you'll do is once you get your CAD kinematic diagram done in AutoCAD, then you're just going to do a screen snip of that. All right. You don't need to hand me the file. Don't submit the file for me like the AutoCAD DWG file. You're just going to do the, picture, the screen snip of it and then upload that. Does everybody know how to do that? If you don't, if you need help when you are working, I can help you with that. Now you can upload the separate screen snips if you want to, or you can put them into, for instance, a Word document or a Google Doc, and then just plop them in place and label them. It's up to you. I accept them either way. I don't want to make that a big production. Okay. And then your mobility equations, you can either add those to the CAD file and put them right there and include them in the screen snip, or you can handwrite those out. And then you can also submit photographs of that. So JPEGs or PNGs. So you can take a picture with your camera on your phone, just making sure that it's legible. Okay. So check your that it's not blurry, check that it's readable so that I can view it then in Canvas. Okay. Again, I don't want to put too many limitations on that or have a big production about how to submit, because it works. I just want to keep it simple as long as everything's legible. So any questions on those? Then there's two other problems in the homework. There are two case studies. Okay, two case studies. There's case study number 1, and it's looking at this mechanism, kind of explains it up here. I'll let you go over that. And then there's a series of questions. Okay, there's a series of questions. So answer those for me. Okay, and just write those out. You can write them out by hand or type them out, whatever you feel most comfortable with, but I have to be able to read it. So if you know that you don't have the greatest handwriting, that's okay. Then just type them out for me, please. Okay. And then you have a second case study, and the mechanism is on the next page. Looks kind of familiar. A version of. And then there's a series of, in this case, 9 questions to ask about how your toilet operates. So answer the questions on that one too, okay? So, yeah. So that's your homework. And then you can just check the calendar to see when those are going to be due, okay? So I'm gonna stop recording. If you have any questions, don't hesitate to let me know.